In this section, we're going to be looking at some more properties of logarithms. The first one's referred to as the product property, and what you do when you're using this property is you pay attention to what you have here in the argument. So the mn, of course, is being multiplied. So you're looking at the fact that this is multiplication. If this is multiplication, then the property says that you can give each one of these factors its own log term. So you do log base b of the first factor, log base b of the second factor, but you have to put addition in between those two terms. Okay, the second property is referred to as the quotient, because what you're looking here, of course, with your argument is that you have a fraction, therefore you have m divided by n. So when you have division, again, it's thought of as splitting it up, but you have to do log base b of your numerator, then do log base b of your denominator, but in this case you have to put subtraction between the two terms. Okay, the last one's referred to as your product rule, power rule, and in this case, when you look at your argument, you see the fact that you have an exponent. So what you're going to do there is take the exponent and bring it and put it in front of the log, so what you end up doing is multiplying the exponent times the log. So we're actually going to be using these properties with two different sets of instructions. One of the instructions will say for you to expand it. So in that case, you'll start out with the problem looking like this, and then you turn it into a problem using these rules on this side. So that's expanding. Then the reverse of that is condensing. In that situation, you'll start out with your problem looking like these, and then you take it and you rewrite it this way. So you'll use these same properties in the whole section, but once to expand and then the other to condense. Alright, the first one that we're going to look at, because as I said, it's commonly referred to as expanding. Okay, when you look at your argument, so here's my argument, I'm looking for multiplication, division, exponent. And this example actually has the multiplication. You actually have three things that are being multiplied, but then this factor happens to have an exponent. So we'll actually be using what I had labeled as the number 1 and number 3 rule. So your first step is going to be take each one of these factors and give each one of those factors its own log term, but then you're going to put addition in between each of those. So I would have log base 5 of the 3 plus log base 5 of the x squared plus log base 5 of the y. Okay, now I can go one more step, because this middle term, its argument has an exponent. So that's using what I had labeled as the third rule. So you would take your exponent and bring it and put it right in front of this term, so therefore you'll have 2 times the log. So the first term will stay the same, and then you'll have plus 2 times log base 5 of x plus the log base 5 of y. So you have taken those three properties and used those as much as you possibly can. So this would be considered to be the expanded form of this. Okay, number 2. Okay, when I look at my argument this time, I see that I have division and I have an exponent. Of course, the division is your fraction, and again, you've got your exponent here. Okay, in this case, your first step is going to be to expand using the second property, which was the quotient property. So you'll have log base b of the 6 minus log base b of a to the third. So when you're splitting up your fraction, you have to use subtraction in between your two terms. Now I have another step because this last argument has the power. So you take your power, bring it to the front and put it in front of your log to indicate the multiplication. So you have log base b of 6 minus 3 times log base b of a. So that is the extended or expanded form of this log. Okay, next one. Now on this problem I actually need to do a little bit of rewriting just of the original problem before I start using the expanding rules. And what I've got to rewrite is the fact that I've got the square root. So you saw this earlier in one of the other sections where if you come across a radical you do need to rewrite it. So this would be log base 4 of x to the 1/2 power divided by 9. Okay, so that's just simply rewriting it. Now that I've rewritten it, now I look to see which of the properties that I can apply. At this point, this one's similar to the one that I just finished because I do have the fraction, I've got the division, and then I also have the exponent. So my first step needs to be take care of the division. So I would have log base 4 of x to the 1/2 power minus log base 4 of 9. So again, the fact that I'm splitting up the division, the fraction, that tells me to use the subtraction between the two terms. And then last, this argument has the power, so you bring the power and put it in front of the log and multiply it. So there's my answer on that one. Okay, next one. Now this one has a radical in it, just like the previous problem did. That's the first thing that I had to rewrite just a second ago. So first thing that I've got to do here is rewrite this one. Okay, so I'll have log base b of x divided by y, but then that whole fraction would have to be raised to the 1/3 power. So the cube root would give you the 1/3 power. Now you do need to have it in parentheses because it is the whole fraction to the 1/3. Now on the three previous problems, the first thing that or the last thing that I did was to take care of the exponent. But this time I actually need to take care of the exponent first because it is the entire argument to the power. It's not just the x or just the y. It's not just a piece of your argument, it's the whole argument. So if I bring the 1/3 to the front, okay, so now I'll have the 1/3 times the log. Now I take care of the fraction. Now, when you take care of the fraction and you take this division and you split it into two terms, and you put your subtraction sign in between, the 1/3 still has to be multiplied times that whole thing because the 1/3 was the power on the whole argument. So because you're turning it into two terms, you're going to have to put all of that in a set of parentheses. So the 1/3 multiplied times all of it. So you'll have log base b of x minus log base b of y. Now if you distribute the 1/3 and put the 1/3 in front of this one, 1/3 in front of this one, then that would be an equivalent answer. Okay, next. Okay, now this one is actually taking all three properties and putting all three of them into one problem because you do have the multiplication that you have here in the numerator. And of course, you've got the fraction, which indicates the division, and you also have some exponents. Alright, so in this case, first thing you do is take care of the fraction. So we need to split that up. And I'll have log of my numerator minus log of my denominator. Okay, next step, I'm going to take care of the multiplication that I have here. So this term will be split into two terms, but then I would need to put a plus sign between those two. So I'm going to have log of x squared plus log y minus log of z to the 7th. And now I have one last step, because actually the first term, this argument, and the last argument both have exponents. So the 2 needs to come to the front, the 7 needs to come to the front. So there's my expanded form for this one. Okay, we're going to do one more in which we expand, and then we'll actually look at using the properties in the other order where we condense. Okay, now as far as using just the three properties that we've been using today, this is a very basic one, but it does have one thing that's a little bit different that you haven't seen on my previous examples. So first of all, I see that I have the multiplication, the 32 times the x, so I am going to split this up. That means I have to use addition between the two terms. Now, this term I actually can do something else with. Now, it's not one of the three properties we talked about today. It's actually one of the properties that we dealt with in an earlier section, and I'm going to write that property to the side. What we learned earlier is that if we have log base b of b to the x, then that's just equal to x. Of course, in order for this to work, the two numbers you have here have to be the same. Now, what I have as my base on this example, of course, is the 2. But I actually can rewrite 32 as 2 to a power, so I will actually be able to apply this property. So if I rewrite 32 using a base of 2, that would have to be to the 5th power. So according to this property here, this first term is just equivalent to just 5. So you would simplify this just to be 5 plus log base 2 of x. So just be aware, of course, you know, when you have an actual number as your base and your argument, that this property might be something that you can do. Any of these in which you have variables, like my argument has the x there, you know, then there's not going to be this property incorporated into that problem.